Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a 2020 STI Subaru. A very nice sports car, or at least that's what they say. I know some people disagree, but we're not gonna dig into that. Now, it has a really interesting problem. Let's get the customer states paper. We have no codes. I'm trying to get my car tuned and my DAM drops to 0 and stays that way. Car drives fine, check engine is flashing. I believe I hear my cooling fans kick on and my fuel pump prime constantly. It says here contently, but I think it's autocorrect. I think that should be continuously. So the engine, so what we do know, the check engine light is flashing. Flashing means continuous problem. This could be misfire, most likely it is, or timing issue. One of those two, and actually misfire is interpreted, misfire is detected through timing, right? So misfire is technically a timing issue. But it's not the same timing issue as you would have if the timing chain was loose or a tensioner broke or VVT issues. The DAM drops to 0, and that is the most crucial information over here. So the DAM is a dynamic advance multiplier. It actually works closely with VVT. Typically, when there is a problem with DAM and it drops to 0, it's usually when the ECM detects problems with the knock sensor. Now, this could be as easy as over-tightened or not tightened enough knock sensor. It has to be, 17.7 foot-pounds, 24 Newton meters. So over torque or under torque can cause this issue, so definitely check that. But if it's dropping to 0 and stays at 0, essentially ECM is saying that this we're in a dangerous situation, right? The readings from the engine are not making sense. If the car drives fine, I would suspect that it's not an actual damage to the engine, right? So it's not the ECM detecting that the engine is skipping or something like that, but rather the measurement errors. The muff doesn't muff, right? And that would be the problem here. So what we have to do today is we have to test the ECM just to eliminate simple issues. So we're gonna do the power test. We're gonna do the thermal imaging to see what's turning on, what's not. On these, what you want to see, obviously MCU needs to light up. The IC501, that's going to be lighting up. That's what delivers power, essentially. That's what controls these two transistors here. These two will light up, or should. And I think IC705 also lights up. So these are the ones controlled from main 12 volts. Now, if I remember correctly, this cap, this resistor should be lighting up, and there should be another resistor around here that should be lighting up. That's the resistor that supplies these two chips. So that's what we want to confirm. Now we could check the capacitors and stuff, but I don't think this would be a capacitor issue, not on the 2020. If this was 2002, yeah, I would suspect that maybe caps are dead, which could sometimes result in weird issues, sure. Now, too bad we don't have, because customer only delivered the board alone. With no box. Usually, because on the box it tells you the part number, so I can quickly find the part number and see how much the replacement would be. And that's usually, instead of digging into the ECM, let's just see if the replacement is cheaper, then I'll just clone it to the replacement. If it's cheaper than the service, right? But in this case, we don't know, but we'll check that. Right now, we're just doing the initial issue. Now, or initial measurements. Now, why does the check engine light why is the check engine light flashing, but there are no codes? It's very unusual because any scanner should detect those codes, especially if it's flashing. Because if it just lights up, that means the code was stored, right? It was detected, but it's not a current issue, right? So if you had misfire for 3 cycles and it went away, then the light is just gonna stay on. If there's I don't know, catalytic converter issue detected or anything like that, the light will stay on. But if the light is flashing, that means we currently have misfire or some other issue. In this case, we don't have any information regarding how the car idles. So we need that information. Is it smooth? If it idles well, then it's not a misfire. Is there any power drop? Did it lose any power? Those are kind of important details that we need to have. I didn't ask for them yet, that's why I don't have them, because first we want to just check for the easy stuff. And most likely what we're gonna do here is we're gonna reset VVT, because, well, we also don't know the history, right? Was there like an engine swap? Was the ECM replaced? Anything like that? Was there any work on the engine done, right? Perhaps timing chain was replaced or something like that. In those cases, VVT should be reset, and that would explain the issues. The dam going to 0 is also explained by VVT if the VVT is the core issue over here. If it's the source of our problems here, then that would definitely explain it. Now, this also could be as simple as viscosity of the oil. I've seen that issue before. It's relatively rare, but it happens. It happens. So either the engine is starved from oil, or there's too much oil, or the oil is, the viscosity of the oil is not correct. All that can cause this issue. Now, we won't be able to read the codes now, right? So I believe that the customer's code reader is not seeing anything. And typically when that happens, when you have those cheap little CAN readers, they will give you the DTCs like misfire and stuff like that. But if there's problems with emission, or essentially mainly emission data, they don't read that. They only read in mode, what was it, 8 or something, it doesn't matter. They only work in one mode. But if the light is flashing, it definitely should give you a code, because there is an active issue on the engine. Okay, so first the power test. Let's drop the current to 300 milliamps, and let's see. Yeah, we got we got CC because it was starting, so we started it, which is fine. Yeah, 3.4 watts. So and we have CAN high and low. I don't know if you can see that, but the CAN is working. So let's grab a thermal camera and let's see if everything turns on as we expect. Now, I don't expect any shorts or anything, because we would see much higher power consumption if there was a short on power lines. But there still might be short on the NOx sensors, or a problem of the NOx sensors, so we have to check that. So first, let's see. Okay, MCU is on. Yeah, we have the array over here. And there's that resistor that should light up. Yeah, let's see if it's not burning my hand. It's not. IC501 is on, So everything is fine here, and let's see the back. We have one resistor heating up over here, the back of the transistors, back of IC 501. Yeah, everything looks good here. So both power test and thermal imaging is negative for any faults. Next on the list, turn off, switch to 3 amps, connect the scan tool. Now let's turn it on. Let's go to OBD2. Let's do auto scan. There you go, it read very quickly. Now let's read codes. And we do have a NAC sensor. Yeah, okay, 12. So intake, throttle position, all that, absolute pressure, all of that, intake temperature, that is all good. But we have a MAF issue, 102 and 328, NAC sensor circuit high. It should be circuit low when connecting like this. So this is your issue. You have a problem with the NAC sensor. So, well, in that case, let's just start digging a little further, but something tells me that we're gonna have to replace the ECM. Because usually with these issues, it's an MCU issue. Although I don't see anything immediately, suspicious or wrong with the MCU here, it can be a subtle issue. Because the NAC sensor should go directly to the MCU. So usually, if there is an issue, there's basically nothing else there, essentially. That's why it's usually, I call it an MCU issue. It might actually be something else. But there's basically nothing else in between the MCU and the sensor. But we'll confirm that. I don't think I've worked on 2020 before, but it looks exactly the same as 2019, 2018, 2017. So I don't expect it to be built differently. So let's see, that was front NAC sensor, right? Okay, and let's check between the ground and the sensor. We are open. And let's see the shield. The shield is on the ground, which is correct, but the sensor is open. Let's see if we can find what is actually connecting to this pin. Okay, so the pin doesn't seem to be connected to anything. It should beep at the MCU, and it doesn't, which is unusual. Usually when something like this happens, when I can't find where it connects, it's usually the wrong pinout. We had that case recently when the car was supposed to be 2006, but it was actually 2005. I mean, the car was 2006, but the ECM was 2005. I don't see anything that would indicate anything. Well, this doesn't have to mean anything. That's from me scratching the pins, so I can see where it connects. It's fine. Now, just to be clear, just because I can't find where it connects doesn't mean it doesn't connect anywhere. It obviously goes to like they usually do, the sensors. They go to the center layers of the board, so I can't just trace it like that on the board. Now what we could do, and actually let's do that. Let's inject a little bit of voltage into that rail and confirm that it's not taking any power. It shouldn't be taking any power. If it does take any power, then we're gonna see what's getting hot. 0.8 volts. And let's see, is it taking anything? Nothing. Yeah. So it's good. I mean, it's good. If it was taking any power, we would see the voltage drop on the multimeter, and we see nothing. So it's like completely open. Typically, they're not supposed to be open. Let's check the 2019 similar ECM. This is 2019 STI. almost the same. Yeah, you wouldn't even know which one's which, right? Exactly the same ones. And let's confirm that the knock sensor on this one also is open. Okay, it's also open. So this is probably good. And as I said, even if we detect any issues with the knock sensor on the ECM side, there's not much we can do other than just replace the ECM. So I would lean to the conclusion that all we can do here is just reset VVT. If the VVT reset doesn't resolve the problem is not on the ECM side, at least not this one. It could, those issues could result from the ECM, but in this case, I mean, if they were, we would see something on either on the thermal image or on the power test. Both thermal and power are negative for any issues. Knock sensor, at least I don't see the short. I mean, that explains it. If it's open like this, then that would explain why it's reporting high instead of low, at least on these. Typically they report low when I connect them on the bench, but you know, those especially STIs are much different than all the other ones. So what we gotta do is first call the customer. Well, actually first we're gonna publish the video, call the customer, offer an VVT reset in hopes to resolve the problem, but if the VVT reset doesn't resolve it, it's not an ECM issue. So I would start with the knock sensor, and then I'll give you a list. I'll give you a list of what I would recommend doing to isolate the problem. Now we could also, these could be as expensive as like $300, so it's very much worth doing VVT reset first. But we could also just replace the ECM altogether, and that would definitely eliminate an ECM as being a culprit. And in this case, I don't think it is, if the VVT doesn't help, because it could be as simple as VVT reset and everything goes back to normal. So let's publish the video, let's call the customer, and let's see what he wants to do. And that'll conclude this diagnostics session. Thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.